Good morning, students. In this lecture 63 of electronics, we will discuss our next one of the most important topic, which is always there in exams of Punjab University, Chandigarh, most of the times. So the article is analysis of common emitter transistor amplifier using H parameters. So what we will do, we will use hybrid parameters to analyze the common emitter transistor amplifier. And this topic, it will be covered in 2 videos. And most of the times what happens is that the students, they just watch first part of the video and they don't even care about the next 2 videos or next 3 videos related to that topic. So watch both the videos of this topic because this is most important topic of this unit. So first of all, consider NPN common emitter transistor amplifier. Here we have the circuit diagram. This is common emitter NPN transistor, where RS is the source resistance, RL is the load resistance, VCC is the voltage which is reverse biasing the output circuit, and VBB is the voltage which is forward biasing the input circuit, that is base emitter circuit. And this Vs, it is the source voltage of this common emitter transistor amplifier. So first of all, write the equations of hybrid parameters for this common emitter transistor amplifier, which we have already covered in our previous video, that is lecture number 62. So what are the equations, 2 equations of hybrid parameters in case of NPN common emitter transistor amplifier? The 2 equations are, VB, it is equal to HIE IB plus HRE VC. Suppose this is equation number 1, and the second equation for the output current is IC, and it is equal to HFE IB plus HOE VC, and suppose this is our equation number 2. So these are the 2 hybrid equations of transistor in common emitter mode. Now, by using these 2 hybrid equations, draw the hybrid equivalent circuit diagram of this circuit. So, this is the hybrid equivalent circuit of common emitter transistor amplifier by using these 2 equations, which we have already discussed in our previous video. But in this case, Vs is the source voltage and Rs is the source resistance. So, what will be the additional things in this diagram? It will be Vs and source resistance Rs. So, we will connect to this input port 1 a source voltage Vs and a series resistance, source resistance Rs to this input port 1 and suppose there will be some resistance of this input port also, and suppose that ZIE, it will be the input impedance or input resistance of the input port. Similarly, on the output side, we have load resistance RL connected to the collector. So, to this output port 2 connect load resistance RL. And suppose of this whole output circuit or of this whole output port, ZOE be the output impedance. Now in this article, what we will do, we will derive the expressions for current gain, voltage gain, power gain, input impedance, output impedance, overall voltage gain and overall current gain in terms of hybrid parameters. So first we will derive the expression for current gain. So first we will derive the expression for current gain, and we know that current gain is denoted by AI, and as we are using the transistor in common emitter mode, so we will use AIE. This is the representation of current gain. And according to the definition of current gain, what is current gain? According to the definition, it is the ratio of output current to the input current. So what will be the output current here? Output current will be the current which is flowing through resistance RL. And suppose IL be the current which is flowing through RL. So what is output current here? It is the current which is flowing through resistance RL, and that is IL. So it will be the ratio of IL divided by what is the input current? Input current is IB, which is flowing through impedance HIE. So here this current gain, it is the ratio of IL and IB. But see, at this terminal 2, if you apply KCL, according to KCL, what will be the relation between IC and IL here? The direction of IC and IL is opposite, but magnitude is equal. It means IL, it is equal to minus of IC. So this IL, it is equal to minus of IC. So current gain in case of common emitter transistor amplifier, it is the ratio of minus IC upon IB. And here this negative sign, it indicates that output current is out of phase with the 180 degree out of phase with the input current. And now suppose this as equation number 3. And now what we have to find? We have to find the value of IC or IB. Then we will put that IC or IB in terms of H parameter in this equation number 3. So if this IL, it is the current flowing through this RL. So because of this current flowing through this load resistance RL, there will be some voltage drop. So what will be the voltage drop across RL? It will be equal to VC. So VC will be the voltage drop across RL. So calculate it. Voltage drop across RL, it is VC and it is equal to IL into RL. And we know that this IL, it is minus of IC. So this VC, it is equal to minus IC RL. And suppose this as equation 4. Now put this value of VC in this equation 2 of hybrid equation 2 of collector current IC. Put the value of VC is equal to minus ICRL from equation 4 in the equation number 2. So put this value in equation 2 and we get IC, it is equal to HFE-IB plus HOE into minus IC-RL. And now move this term to left hand side. Now take IC common and you will have 1 plus HOE RL and it is equal to HFE IB. Now find the value of IC. It is HFE IB upon 1 plus HOE RL, and what we have to find is the ratio IC by IB. So move this IB to this side and you will get the ratio IC by IB. It is equal to HFE upon 1 plus HOE RL. And suppose this as equation 5th and put this value in the expression of current gain, which is our equation 3rd. So we get the expression for current gain AIE, it is equal to minus IC by IB, means it will be equal to minus HFE upon 1 plus HOE into RL. So this is the expression of current gain. And suppose this as equation number 6th. Now it has one special case. What is the special case? If in case this HOERL, this term, if it is very much smaller than 1, then you can ignore this term as compared to 1. Then current gain AIE, it will be equal to minus HFE. And what is this HFE? It is the forward current transfer ratio. And it is the ratio of output current to the input current. And in case of transistor, what is the ratio of output current to the input current? It is current gain. And what is current gain in case of common emitter amplifier? That is beta. So AIE, it will be equal to minus of beta. And this negative sign, or you can say that this negative sign, it indicates that the output current, it is out of phase, 180 degree out of phase with the input current. And now in the next part, we will find the input impedance, expression for input impedance. And this input impedance, it is denoted by ZIE. And according to Ohm's law, what is this ZIE? It will be voltage divided by current. And according to Ohm's law, this is input impedance. So it will be the input voltage, that is VB in this case. It will be equal to input current, that is IB, into input impedance, that is ZIE. So what is input impedance ZIE? It is the ratio of input voltage to the input current. And suppose this equation as equation number 7th. This is equation number 7th. And we have to find the values of VB or IB in terms of H parameter. And we need to find the expression of input impedance ZIE in terms of H parameters. So now use first equation, hybrid equation, using equation 1, which is VB is equal to HIE IB plus HRE VC. This is the first hybrid equation. And we have already calculated the value for VC. From equation 4th, VC is equal to minus ICRL, and put this value in this equation number 1. So use equation 4th. Use equation 4th in above equation. which is VC is equal to minus ICRL. Put this value here and you will get VB is equal to HIE-IB minus HRE-ICRL. And then we need the ratio of VB and IB. So now divide this equation by IB. Dividing both sides by IB, and what you will get? You will get VB by IB. It is equal to HIE. IB and IB will be cancelled out. Minus HRE-RL IC upon IB. And we know that this negative sign and this IC by IB, it is equal to current gain AIE. So use minus IC by IB, it is equal to AIE, and our expression will change. ZIE, it is equal to VB by IB, it is equal to HIE plus HRE-RL into AIE. Now put the value of AIE, and what is the value of AIE that we have derived in the first part? So expression for ZIE, it is equal to HIE plus HRE-RL into expression of AIE is minus HFE divided by 1 plus HOE-RL. So the expression for input impedance is HIE minus HFE HRE-RL upon 1 plus HOE-RL. And suppose this equation as equation number 8. Now in the next part, we will derive the expression for voltage gain, and it is denoted by AV, E because we are using common emitter amplifier, and we will cover this topic in our next video. In our next video, do watch next video, because in that video we will cover our expressions for voltage gain and power gain and output impedance.